As many of you are aware, on September 23, 2017, the new respirable crystalline silica regulation for construction will be enforceable, and this video serves as a training tool to prepare you for what you need to know. Crystalline silica is a naturally occurring substance used in a wide variety of industries and construction operations, such as the production of cement, sandblasting operations, production of glass and ceramics, and as a filter for water and sewage treatment. It is also a common additive in food and pharmaceutical applications and is used in the production of fiber optic cables. While silica has many valuable uses, it can also present a danger when workers are exposed to excessive amounts of crystalline silica dust. In fact, each year there are hundreds of deaths and thousands of illnesses attributed to harmful exposures to silica dust. To prevent these types of harmful exposures, OSHA has developed regulations for general industry, maritime operations, and the construction industry. This program discusses some key requirements from these regulations, as well as some safe work practices that employees can follow to protect themselves from harmful exposure to crystalline silica. Okay, by the end of this presentation, you should be able to tell me what silica is, where it's found on our job sites, and how it is a hazard. You should also be able to tell me what OSHA requires of you when you are exposed to respirable crystalline silica. This will include certain regulations found in Table 1, alternative methods of protection, housekeeping, a written exposure plan, and the competent person requirements. Okay, if we're looking at what is silica, crystalline silica is also known as silicon dioxide. Silica is a component of granite, sand, cement, rock, and many other materials. Silica is a naturally occurring chemical compound found in the Earth's crust. The most common form of silica is quartz. Two other forms of silica are cristobalite and tridymite. These various forms of silica can become dangerous when extremely small particles, often called silica dust, are inhaled into the lungs. OSHA refers to this type of inhalable silica dust as respirable crystalline silica. And as you can see from the list here, where it's found on our job site, it's in the asphalt, brick, cement, concrete block, drywall, grout, sand, soil, any items that you come in encounter with each day on the job site. Okay, when we look at how is silica a problem, these various forms of silica can become dangerous when extremely small particles, as I said, often called the silica dust, are inhaled into the lungs. This is the respirable crystalline silica. Okay? Anytime you hear the term respirable crystalline silica, it is referring to silica dust that can be inhaled into your lungs. Some operations that generate this respirable crystalline silica include cutting, drilling, or grinding any type of material that contains silica. Also, employees working in manufacturing processes that utilize silica, such as glass manufacturing or foundries, may also be exposed to respirable crystalline silica. This type of potentially harmful silica dust can be so small that it cannot be seen with the naked eye. This is why it is so important to always take precautions in order to avoid harmful levels of exposure. As you can see from this picture, respirable crystalline silica is typically at least 100 times smaller than an ordinary piece of sand found on beaches or playgrounds. The grain of sand is about 90 microns in diameter, whereas a human hair is about 50 to 70 microns in diameter. A particle of dust, pollen, or mold, while it's less than 10 microns in diameter, when we compare it to a particle of respirable crystalline silica, it is actually less than 2.5 microns in diameter. Crystalline silica is classified as a carcinogen of the lungs, and a carcinogen is a substance that has the potential to cause cancer. As workers inhale tiny silica particles over time, they are at increased risk of developing serious and often deadly silica-related illnesses. In addition to lung cancer, another disease associated with the inhalation of silica dust is silicosis. Chronic silicosis, also known as classic silicosis, is a fibrotic lung disease that typically occurs after many years of low to moderate exposures to silica dust. Silicosis causes scar tissue to form in the lungs, and as the disease progresses, the victim may experience shortness of breath during exercise and have clinical signs of poor oxygen or carbon dioxide exchange. In severe cases, silicosis can be disabling or even fatal due to respiratory failure, and there is no known cure for silicosis. A less common form of silicosis is acute silicosis. This form of silicosis occurs after exposures to very high concentrations of silica. Symptoms can include severe disabling shortness of breath, weakness, weight loss, and acute silicosis often leads to death. Breathing in silica dust has also been linked to the acceleration or severity of such diseases as tuberculosis, emphysema, kidney diseases, chronic bronchitis, and chronic obstructive pulmonary disease. Okay, what does OSHA require? In order to protect workers from contracting diseases due to respirable silica exposures, the Occupational Safety and Health Administration has issued respirable crystalline silica standards for general industry, maritime operation, and the construction industry. When air monitoring determines that airborne levels of crystalline silica have reached the action level of 25 micrograms per cubic meter of air, averaged over an 8-hour period, the employee must implement certain requirements of these OSHA regulations. One such requirement is to have a written exposure plan for silica that outlines the tasks in the workplace that involve exposure, the engineering controls, the work practices, and respiratory protection used to limit exposure for each task, and the housekeeping measures to be used to limit exposure to silica dust. OSHA's construction standard specifically requires a competent person be assigned to implement the exposure control plan. OSHA has set the permissible exposure limit, often called the PEL, of crystalline silica to be 50 micrograms of respirable crystalline silica per cubic meter of air, averaged over an 8-hour workday. OSHA requires organizations to use engineering and work practice controls as the primary means to limit worker exposure to respirable crystalline silica to below the permissible exposure limit of 50 micrograms per cubic meter of air. When engineering and work practice controls cannot adequately limit exposure, then the OSHA regulations require that employers provide appropriate respiratory protection to reduce exposure to permissible levels. The OSHA standards also require that regulated areas be established to limit employee access to areas where exposures exceed the permissible exposure limit. The posting of warning signs at the entrances to regulated areas is required. To ensure that employees are aware of air sampling and exposure monitoring results, notifications should be provided to employees in writing or by posting the results in an area that is accessible to all employees. What is Table 1? The construction industry presents many challenges when it comes to air monitoring employee exposure to silica dust. For this reason, the OSHA construction regulation includes a specific table titled Specified Exposure Control Methods when working with materials containing crystalline silica. Commonly called Table 1, this useful table matches common construction tasks with OSHA's recommended silica dust control methods. Table 1 of the construction regulation contains 3 columns of information. The first column lists the equipment to be used or the task to be performed. The second column lists the appropriate engineering and work practice controls that should be in place. And column 3 specifies if respiratory protection is required. And if so, what type? When Table 1 is correctly followed, construction workers will not be exposed to harmful levels of silica dust. Because of this, employers who implement Table 1 are not required to measure workers' exposure to silica dust. As you can see, our daily activities include 2 items from Table 1. This is because most items on Table 1 pertain to concrete and masonry work. Daily tests that we perform will be discussed more in depth on our exposure control plan. The 2 items that do pertain to us on Table 1 are using handheld power saws for cutting fiber cement board and using handheld drills, including impact and rotary hammer drills. In both of these instances, you will be required to use the tool equipped with a dust collection system that will be provided by GCI. As you can see, as long as you are using the tool properly and according to manufacturer's recommendations, you will not be required to use a respirator. Okay, so in Table 1, we have to make sure that it is fully and properly implemented if you are following a certain task in Table 1. So in order to make sure you are being given the proper protection from the respirable crystalline silica, again, you must follow Table 1 fully and properly implement the engineering controls. This means that controls are in place and properly operated and maintained, and employees engaged in the task understand how to use them. You shouldn't see large amounts of visible dust when using the dust collection system. If you do, there is a problem and the dust controls are not working properly. Stop using the tool and make sure it is working properly before continuing your task. Another part of that fully and properly implemented statement is to verify that all employees engaged in the task being performed understand how to follow the controls listed in Table 1. So employees engaged in the task refer to the equipment operators, helpers, laborers, and any other employees assisting in the task. Okay, alternative methods of compliance. So employers that conduct tasks not listed in Table 1, which we have discussed, or do not fully and properly implement the engineering controls, work practices, and respiratory protection described in Table 1 of the specified exposure control methods approach must follow the alternative exposure control methods approach. So if you're not using Table 1, you have to use the alternative methods of compliance. Okay? The alternative exposure control methods approach involves assessing employee exposure to respirable crystalline silica and limiting exposure to the personal exposure limit using feasible engineering and work practice control methods and respiratory protection when necessary. Remember that when you are using alternative methods of compliance, PPE is always the last resort to providing protection. You must first follow engineering and work practice controls that can eliminate or reduce the hazard to a permissible level. By far the best way to reduce exposure to silica dust is to eliminate the dust completely or reduce its presence in the work area by the use of engineering and work practice controls. There are 4 general types of engineering controls used to prevent exposure to silica dust. There's substitution, isolation, ventilation, and dust suppression. Substitution is simply replacing silica with another material that is less hazardous, such as crushed glass, nickel slag, or aluminum oxide. Isolation is the placement of barriers around a work area where silica is used. These barriers should restrict silica dust from spreading throughout the workplace. Ventilation is supplying clean air to a worker performing a task that involves silica dust or exhausting air containing dust before it can be inhaled. Dust suppression is when a water-based system is used to prevent silica dust from becoming airborne. For example, wet cutting masonry products is much preferred to dry cutting. Okay, those are all engineering practices. Okay, work practice controls. In addition to the types of engineering controls, work practice controls can also be used to limit exposure. Work practice controls refer to actions that employees can take while working to reduce exposure to silica dust. For example, good housekeeping practices are essential in reducing the risk of exposure. Buildups of dust should be removed with a water hose or by wet sweeping to prevent creating airborne dust. Another option is to use a vacuum with a high efficiency particulate filter, known as a HEPA filter, to clean up silica-related areas. Also, another way of cleaning up the floor would be to use a dry sweep compound. Okay, you should strive to avoid using compressed air or dry sweeping these areas. These methods disperse dust particles into the air and dramatically increase the potential for exposure. Other work practice controls include the use of disposable work clothes when working around silica-containing materials, and to shower and to change into clean clothes before heading home. Okay, in regards to respiratory protection, or the PPE on the hierarchy of controls, in many cases the engineering and work practice controls are infeasible or simply do not reduce respirable crystalline silica exposure to below the permissible exposure limit. When this is the case, employees must use respiratory protection to further limit their exposure. Anytime employees are required to use respirators, the employee must establish a written respiratory program that meets the requirements of OSHA's respiratory protection standard. For many job tasks, a simple N95 NIOSH certified respirator will provide the necessary protection from silica dust. If other types of respirators are selected, be sure that the filter is certified for silica dust and that the respirator has an assigned protection factor of at least 10. Some job tasks, such as sandblasting operations, subject the worker to larger exposures and additional hazards. Sandblasting and similar operations require the use of a type CE positive pressure abrasive blasting respirator. If you have any questions about the proper respiratory protection required for any specific job tasks, be sure to ask your supervisor. Respirator use is prohibited as an employee of GCI unless you are enrolled in our respirator program. This includes the N95 dust mask, which is a respirator. Okay, who is required to have a written exposure control plan? All employers covered by the standard, including employers who fully and properly implement the specified exposure controls in Table 1, must develop and implement a written exposure control plan. Okay, what must be included in the written exposure control plan? Employers must list all tasks that employees perform that could expose them to respirable crystalline silica dust. A description of engineering controls, work practices, and respiratory protection used to limit employee exposure to respirable crystalline silica for each task. A description of the housekeeping methods used to limit employee exposure to respirable crystalline silica. And a description of the procedures used to restrict access to work areas when necessary to limit the number of employees exposed to respirable crystalline silica and the levels to which they are exposed, including exposures generated by other employers or self-employed workers. Okay, employers must allow the written exposure control plan to be viewed or copied by each employee covered by the standard, their designated representative, and representatives from OSHA or NIOSH upon request. Okay, the competent person is going to be the one who frequently and regularly inspects job sites, materials, and equipment to implement the written exposure control plan. You must be able to identify existing and foreseeable respirable crystalline silica hazards, properly eliminate or minimize silica hazards, and implement the written exposure control plan. Most illnesses related to the inhalation of silica dust do not result from one sudden exposure. Instead, they develop after months or even years of exposures. This is why it is so important that you protect yourself in every exposure situation. If you begin to experience symptoms of a silica-related illness, such as shortness of breath, chest pains, or fatigue, follow your organization's policy for reporting your condition so you can be evaluated by a healthcare professional.